What? Another physics project?
Hey Kevin, wanna go grab Taco Bell? I can drive.
Sure thing.
Hey, don't forget your laptop.
Oh, thanks.
Hey Kevin, wrong way.
Oh no, I'm out of gas.
What? How are we going now? But I feel like I'm outfield too. I'm so hungry.
Oh, how are we gonna get Taco Bell? I'm too young to die. Oh.
What are we gonna do?
Guys, are you going to Taco Bell?
Yeah, but the car doesn't have any gas and it can't drive without any fuel.
Why don't we just take the Maglev train then? It runs on electricity, not gas, and it goes much faster.
What's a maglev?
Let me show you a video.
Hello everyone, my name is Professor Zhao and I work here at Hart University. Today I will be educating you guys on magnetic levitation trains, or as it's more commonly known, maglev. The concept of maglev first came about around the early 1900s, but it was never actually put into use until 1979 in Germany. Since then, the usage of maglev trains has expanded into industrialized cities for its more efficient usage, its low maintenance, and its incredible velocity, as many of you guys know, is a vector quantity with magnitude and direction.
How fast?
Maglev trains can easily reach over 250 kilometers per hour. Dang, we get into Taco Bell in a jiffy.
But how does this work so well?
Oh ho, did someone just ask how the maglev train works? If so, I'm here to answer. Here we have an aerial diagram of a maglev train, which is suspended by magnets below it. The blue ovals here represent North Pole magnets, whereas the red ovals represent South Pole magnets. The blue ovals and the red ovals attract each other because they're opposite poles, whereas the red oval and the red oval, as well as the blue oval and the blue oval, will repel each other because they're the same pole. This allows the train to move forward with very little friction, which in turn results in the high speed of 250 kilometers per hour.
Where do we get a maglev train?
Don't worry, we can make an electromagnetic train ourselves. Let me show you how. Take a AAA battery and place two powerful neodymium magnets on each side. They have to be in opposing directions, for example, north facing north. Be careful, these are not toys. Now, I need you to coil some wire into a solenoid. You can use some sort of rod or tube, for example a PVC pipe, to wrap the coil around to make it more uniform.
Okay, I did it.
Great. Now place the magnetic battery train inside the coil and... boom!
Oh my heck! That was so fast! How does it work?
Let's continue watching the video.
Professor, we started.
Oh, my bad. Hello, I'm Professor Chang from Hart University, and today I'll be explaining the battery train. So, basically, there's a battery with two magnets on each side. As you can see, the magnets must be facing in different directions. And these neodymium magnets will conduct current through the battery through this portion of a coil loop, which I have drawn a cross-section of. These coils act as a solenoid and generate a magnetic field throughout this entire coil section, which, because the magnetic field is distributed in a curve like this, will cause the inner north parts to experience a stronger this directional force and the south portions, which will experience a force in the opposite direction. These forces cause a net force on the battery to propel it forward. And this is how the battery train works. This battery train is actually very similar to the maglev trains we see in real life, such as the ones in Germany, South Korea, or Tokyo. Because in a real maglev train, as the maglev train moves, there's a switch that turns electromagnets below it on or off. And in our battery train's case, as it moves, the portion which generates the magnetic field shifts as well. And so, these principles of magnetism are what powers all of these convenient transportations in real life. And people, thousands every single day, use these transportations to move around countries and around different locations. Another further application of these electromagnetic principles is within weaponry. Coil guns and rail guns both use this concept of driving a projectile forward through a coil to very high speeds, and this can be very lethal, as seen with the US military. Thank you for today's lecture, and as always, stay polarized.
Professor, that wasn't funny.
See? Maglev trains let us travel really far in a really short time.
Let's go to Taco Bell now! Whoa!
So, I guess maglevs are pretty cool, huh?